Hello, I'm Agus Ulinuha, and for this opportunity, I would like to present my paper entitled Design and Implementation of Multi-Car Scale Electric Vehicle powered by Brushless DC Motor. I'm writing this paper together with Ibnu Khak and Dimas Septian, and we are from the Department of Electrical Engineering, Universitas Muhammadiyah Surakarta, Indonesia. Background of this research: transportation system dominantly consumes fossil fuels. Moreover, it causes air pollution. That will be a dilemma since transportation sector is required by people, yet it may lead to some drawbacks in the form of huge fuel consumption and the problem on pollution. The solution of the problem is either using natural fuels environmentally friendly or replacing the engine of the vehicle by electric motor. Electric vehicle is now in the beginning stage of development, but the real vehicles are now used and some of them are commercially available. The specification of a vehicle for prime mover. A brushless DC motor capacity is 1000 watts with 48 volts, expected to provide the torsion of 30 to 50 Newton meter. The chassis of the vehicle uses aluminum chassis frame, which is lighter yet more rigid, and the body of vehicle is designed to have the coefficient of drag of 0.4 up to 0.5, and this is aimed to reduce aerodynamic resistance. For energy storage, 40 volt 8.7 ampere hour lithium ion battery is used. It is equipped with battery management system. For the controller, 48 volt 350 watt 17 amps is used, uh, including the ICMC 33035 to drive a MOSFET that controls the PLDC motor speed. Together with PMS, the controller determined the most proper power consumed by the vehicle for the required speed and torsion. This is the chassis design. And the design and mechanical analysis use SolidWorks. The material used is square tube aluminum alloy 6063 35 with a size of 40 times 40 millimeter with with the thickness of 2 millimeter. The size type is letter frame, as you can see in this three-dimensional isometric perspective. This is the chassis strength level in horizontal axis. This the strength level in vertical axis. And for the body design, uh, some factors are considered, including force, drag force, side force, and turbulent force. Aerodynamic characteristic was simulated based on computational fluid dynamics using SolidWorks equipped with fluorescent simulation. This is the vehicle body of the vehicle designed by the team, and this is the uh, simulation on how air is flowing around the vehicle, and this is the pressure on the vehicle simulated by the program. The prime mover of the vehicle is brushless DC motor, uh, and this type of motor is used by considering that it is efficient, it enables providing high torque, and it consumes less power. And the specification of the BLDC motor is the voltage is 48 volt and the power is 1000 watt. The current is from 16 to 18 amps. And the torque is 30 to 50 Newton meter. For energy storage, lithium-ion battery 48 volts, 8.7 ampere hours is used, and it is equipped with a battery management system, 25 amps. For the controllers, uh, MC-33035 is the main component, including the IC that controls the MOSFET. And these components will determine the speed of the LDC motor. How it works, the ICMC33035 executes pulse width modulation depending on throttle opening determined by the driver. The throttle opening given by the driver will determine the speed of motor. And the battery management system is equipped with current limiter to control the current drawn by the motor not to exceed the maximum allowed current. This is the layout of electrical component. As you can see in the figure, the components indicated in the figure including PCB of electrical system, battery, controller, PLDC motor, toggle in the front side, and then display instrument and horn. And the physical layout of electrical component before the body is placed is given in the figure as well. For implementation of the design, as we can see the figures before the body of the vehicle is placed on the chassis. And the vehicle body is constructed using carbon fiber due to its low weight and good mechanical properties. To construct the body, a brick case made from styrofoam reinforced with plywood was made to construct the pattern of the model of the vehicle body. And for constructing the vehicle body, a two-layer carbon fiber was laminated on the model. This is the body of vehicle when it was placed on the chassis, and actually the figure indicates the complete vehicle. And for the testing, the vehicle was driven for achieving 10.35 kilometers, and the vehicle required the total time of 19.52 minutes, and the maximum speed was 53.3 kilometers per hour. The total weight of the vehicle, including the driver, is 131 kilograms. The total energy consumed by the vehicle for achieving that distance is quite low, which is 0.2687 kilowatt hour. This is very small energy, and the vehicle is expected actually to achieve higher speed. The throttle was not fully opened by the driver because he was very careful in driving the vehicle. But actually, the vehicle can achieve higher speed. This is the data from the testing, and the vehicle runs for 23 laps, and it is the distance of every lap, the time, energy, and battery sampling voltage. The voltage of the battery reduces due to some energy was released for running the vehicle. The vehicle is produced following the design, exactly following the design, and therefore the result is as expected. However, there are some friction that still happen, that still might take place, that still take place in the vehicle, and it needs to be minimized to optimize the vehicle performance. That's all my presentation, and thank you very much for your attention.